right, part E. This is a really brief overview of virtualization technologies at a very high level. But as I stressed earlier, virtualization technologies are core to clouds, and in fact, we're changing our virtualization technologies as they're advancing from Openstack as our dominant technology to Docker as dominant and Openstack as sort of in reserve, and in some courses not even taught. Okay, here is an overview. And it also happens to have a bunch of links here, which you can look at. Here they are. And you notice Wikipedia is pretty strong here. And we will go through hypervisors and the different approaches to virtualizations. And we'll mention probably the following technologies: KVM, Xen, Docker, and OpenStack. Where KVM is a hypervisor and Docker and OpenStack are the managers above it. Well, Docker can be above KVM and Xen, but it can also be standalone as a container technology. All right, here's our introduction to virtualization technology. We've sort of explained why we need it. We have to run lots of jobs on the same cluster and on the same node of the cluster because we want to share at the core level. And you really can't use the traditional approach of sticking software in /bin/lib//bin//lib// There's too much software needed to get everything to work. The software changes. The different configurations, you have to have an OS configuration. You've got to keep those separate from each other for each job, and that's pretty hard to do. And also, when you intermingle anything, multiple jobs, that has security issues. So this requires some sort of virtual machine. It doesn't say how it has to be done, but it needs a virtual machine which preserves the illusion of say a Linux or usually Linux, but sometimes Windows machine. And that whole machine runs on top of your hardware, and each job has its own machine. Now, which is then treated independently. And I've stressed why that's particularly important with multi-core. If we look at the machines we have, Tango has 68 cores, 68 cores per chip. Victor, which you'll use later, it has 48 on 224 core Xeon Platinum chips. And you use hypervisors or virtual machine, which are virtual machine monitors, which is some sort of computer software or even hardware that creates and runs these virtual machines and translates the actual call of the captured program in the virtual machine into the real call running on the hardware. So the machine in which it runs on is called the host. That's a reasonable name. And each of the virtual machine is called a guest. And depending on the technology, the guests have the same operating system or a different operating system from the host. And hypervisor is just meant to say that, well, it's a really important thing going on. It's buried in the past. This term was invented a long time ago. And it's a variant of supervisor because originally all this technology of running computers was called a supervisor technology. All right, so now we have a little more detail on the technologies for virtualization, which there's this well-known division into type 1 and type 2. Type 2, sort of where you have an actual OS running on the real hardware. So this is a real job, OS on hardware, no virtualization. That supports the hypervisor, which then supports the guests. Here we have 3 guests. In type 1, the hypervisor runs on the hardware, and the guests run on the hypervisor. And in some cases, you can modify the guest OS to make system calls to the hypervisor rather than executing machine I/O instructions, which the hypervisor simulates. That's called paravirtualization. All right, and so since 2005, hardware virtualization has been around as an alternative to para-virtualization, and that's, we started, all this virtualization started long before 2005, because IBM found it pretty useful for their early mainframes, and they actually pioneered this. Here's a nifty remark from 2017, in November, which says that effectively Amazon is shifting some or all of their technology from Zen up here, type 1, to KVM down here, type 2. Again, that was not, it was sort of slightly secret announcement. Now there's this other thing, other approach called operating system level virtualization, which uses the fact that Linux actually has the technology to virtualize built into it. It's called containers. And you can isolate user space instances in Linux. It is not quite as secure as the hardware style virtualization, but it has huge advantages in terms of performance and ease of use. And this is what Docker implements. And there are other technologies besides Docker. Docker just sort of made this popular by making it particularly easy to use. So when you're running in a container, you see the contents of the container and the devices assigned to the container. And there's almost no overhead because you're running on the real hardware with the real OS. It's just the real OS has the necessary technology to support multiple containers. Now you have to still have a single OS in this case, whereas in the guest cases, the guest has the OS, and that OS can be different for each virtual machine. But there's an advantage from this because you don't have the OS in Docker, because Docker itself effectively runs the OS. Then all your images are smaller. They just have your application code, which tends to be less, not as voluminous as the application plus operating system. So we will be using Docker, and it's built on top of conventional Linux capabilities, and it's much easier to use, and it's much lower performance because everything's running in hardware. Whereas, say, now when you do Openstack, you're doing all sorts of software networking and things like that, which makes it very slow. We once, when we were last running Openstack for a large amount of time, we spent over a day just recovering from a crash because due to the network overheads of the way OpenStack did things. There are some security issues which are worth studying, but now gradually going away. And there's Kubernetes, which manages lots of Docker instances, and it supports, therefore, sort of parallel computing or large jobs or hyperscale computing. Now, as well as that, we should contrast this with OpenStack, which is not really, it's not a hypervisor. It runs on a hypervisor and then manages the cloud. And they do give you software emulations of things that you'd want to have inside your virtual machines. And OpenStack typically runs on KVM, but you can run it on the other hypervisors as well. And OpenStack is a huge project. It's got lots and lots of sub-projects. 6 compute projects, almost like Amazon and its services. And there are 3 data projects, 5 storage projects, 7 network projects, 4 security projects, and so on. Lots of projects. All of these are open source. They all go to the OpenStack meetings. OpenStack has a new release every 6 months. You need a large system staff to run OpenStack. That's one reason we gave it up. We too much support needed. Here are sort of for those many capabilities. These are the ones you typically use. Nova, which is equivalent to EC2 on Amazon. Neutron, the networking. Swift, the object store. That's equivalent to S3. Glance, the image service. Security Keystone, and Cinder, storage on the actual disk on the computer. And here is a comparison of the different virtualization technologies. We start with the infrastructure. Remember, that's what Amazon originally sold us. Then we have a host operating system. This is for type 2. Then we have the hypervisor. And then this is for a KVM type scenario. Here we have Docker running. This is the Docker scenario. We have Docker running on the operating system. And then we have these applications in their own containers. And then if we have KVM, then we have the 3 different applications have the OS, the guest OS. Oh, I miss guest OS. Wow. And but otherwise they have the same application as back in the Docker case. So we replicate the OS, and we have this overhead of guest OS, hypervisor, host OS. Whereas Docker host OS, and just a little if statement in the Linux kernel to decide which of the different containers it's running. All right, so that is a very, very crude description of what's going on, but we'll come back to it in more detail later on. Thank you very much.